faithfully delivering value, interpreting great books from around the world. Hi, this is Sally's Book Talk. Today, I'm diving into the future of space for you. Back in 1961, the Soviet spacecraft Vostok 1 made its first successful trip into space. Legendary astronaut Yuri Gagarin became the first human to leave Earth's atmosphere. Then, in the next decade or so, the US Apollo program put humans on the moon. At, in the 40 plus years after that, human space exploration has seemed to slow down quite a bit. Lately, some folks argue that IT tech's progress and spread have made it seem like tech is advancing super fast. Actually, in other tech areas besides IT, from the 1960s to now, humans haven't made many breakthroughs. This is especially clear in space exploration. So, what level has human space tech really reached by now? What's next on the agenda? And what bottlenecks has space tech development hit? The Future of Space dives into these confusions. The author of this book, Zhao Yang, holds a PhD in history of science from the Chinese Academy of Sciences and is a member of the China Association for Science Popularization Writers. The Future of Space covers the history and current state of human space efforts, plus sketches out possible future paths. Crucially, these predictions aren't sci-fi, they're built on solid tech foundations. Renowned sci fiction author Liu Cixin wrote the foreword for this book. He mentioned that for the ethereal astronaut dreams in the Three Body series, the author offers solid scientific explanations. This book tackles two main questions. First, what's the outlook for human development in the solar system? So, second, what challenges need tackling to make this blueprint a reality? Based on today's tech and ongoing experiments, the outlook for human development in the solar system is this. First, develop space tourism. If space stations handle work and living in space, then we'll need space hotels for tourism and vacations. In 2001, American billionaire Dennis Tito paid big bucks to ride the Russian Soyuz to the International Space Station. He spent 6 days there, becoming the first self-funded space tourist. How much did he pay for that trip? The answer is $20 million. That astronomical cost is way beyond most people's reach. But space tourism companies like Virgin Galactic believe that someday low Earth orbit and even the moon will become must-visit destinations on everyone's bucket list. Actually, back in 2016, Virgin Galactic started pre-selling tickets for Spaceship Two at $250,000 each. Definitely not cheap. Though compared to $20 million, $250,000 seems way more reasonable. Just note, Spaceship Two only reaches suborbital space about 100 kilometers up, and the whole trip lasts just 3 hours. Compared to a week on the ISS, this setup seems basic, but the value's actually pretty solid. So by early 2018, over 700 wealthy folks had already booked tickets. If all goes well, this route could launch within 2018, marking a major milestone for space tourism. As more companies enter the market and it expands, space travel costs will inevitably drop. By 2030, you might just need $1,000 for a suborbital trip. That's about what a Southeast Asia vacation costs today. Just imagine, with rockets roaring, you gaze through the window into pitch black space as our beautiful blue marble planet drifts into view. What an absolutely breathtaking sight that would be. Don't forget to snap that perfect shot, freezing yourself against that iconic WeChat launch screen backdrop. Beyond short suborbital hops, actual space hotels are being developed right now. In late 2017, Roskosmos unveiled plans for a space hotel, complete with concept art and proposals. If this plan succeeds, Earth's first orbital hotel could welcome guests by 2022. Meanwhile, America's Bigelow Aerospace announced lunar orbit hotel plans targeting 2022. Seems these new destinations just 100 kilometers away are nearly within grasp. The second development prospect, we might build actual space cities, orbital colonies. Currently, there are two space stations orbiting Earth, the International Space Station and China's Tiangong 2. The ISS is way bigger than Tiangong 2. Its internal volume is 1,200 cubic meters, and the module stretches 74 meters long, about the length of 3 basketball courts. Oh, for a family living there, it's spacious enough, no doubt. But considering space stations hold the future of all humanity in space, today's versions are still too small. Looking at current trends, space stations are bound to evolve towards being larger, easier to maintain, self-sustaining, and more comfy. Back in 1974, Professor Gerard O'Neill from Princeton University first floated the idea of space cities. O'Neill believed Earth's environment has hit its limit for supporting human and other life forms' growth. If humanity wants to keep thriving, one path is migrating to space and living in space cities. O'Neill imagined space cities as pairs of cylinders, spinning opposite ways around a shared axis, creating centrifugal force to mimic gravity. Like when a washing machine spins clothes dry, the fast rotations, centrifugal force pushes the clothes against the drum wall. A space city is like a huge washing machine drum, with its inner walls hosting setups for plant growth, forming grasslands, forests, lakes, and rivers. Space residents would live and work happily in such settings. O'Neill reckoned that with today's tech, if developed nations commit to this, we could totally build space cities for 10,000 people within a century. Maybe one day we'll see small space cities dotted across near-Earth space like sparkling gems. Shuttle ships like high-speed trains would ferry regularly between space cities, their exhaust trails drawing white threads that link the gems, draping Earth in beautiful necklaces. Whether space hotels or cities, they're all floating up there to truly become masters of the solar system. The third development prospect is finding more solid bases in the solar system. Humans are eyeing the moon and Mars to terraform them for habitation, but the most likely near-term move is setting up semi-permanent bases on the moon. The moon is Earth's closest celestial neighbor and humanity's first step into the solar system. Back in 1969, the U.S. Apollo 11 mission landed astronauts on the moon. But over 40 years later, human activity on the moon remains limited to that small step from the Apollo program. The main reason? Humans don't have proper housing on the moon. We can't imagine Antarctic researchers spending half a year in temporary tents. Similarly, future moon settlers can't live cramped in tiny capsules forever. They need decent homes. Wendell Mendel, head of NASA's Johnson Space Center in Houston, once presented the White House with detailed moon base plans. First, launch lunar satellites to scout the best construction sites. Second, transport construction equipment to the moon. Think cranes and excavators using microwaves to harden foundations, kind of like site prep for Earth buildings. Third, set up temporary work huts. Since there's no oxygen, these pressurized pods would actually be nicer than Earth construction shacks. Finally, lunar workers would mine oxygen, aluminum, iron, titanium, and silicon from moon rocks to make breathable air and construction materials, then gradually expand the base. Like all mega real estate projects, Mendel's plan costs a fortune, projected at hundreds of billions over a century with generations of builders. Such massive projects likely exceed any single nation's capacity. In the future, moon-based construction may follow the International Space Station model, built through multinational cooperation. With a moon base established, humanity's next solar system target is conquering Mars. Mars features in countless sci-fiction novels and films. Humans have studied crewed Mars missions since the 1950s, yet even now no human footprint marks Martian soil. Currently, the US, Russia, and Europe all have concrete, crewed Mars plans aiming for that giant leap around 2030. Truth is, our ultimate Mars dream is terraforming, technologically reshaping it into humanity's second home. Today's Mars is barren wasteland with no signs of life and an atmosphere so thin its pressure is under 1% of Earth's. Oh, worse yet, in this thin atmosphere, 95% is carbon dioxide with almost no breathable oxygen. Robert Zubrin, founder of the Mars Society and a scientist, believes making Mars's atmosphere breathable could take around 1,000 years. Compared to a single lifetime, 1,000 years feels super long, but in history's grand scheme, it's just a blink. The key to terraforming Mars is using space mirrors to reflect sunlight onto the polar caps for evaporation. This involves ice on Mars, like dry ice from CO2 and water ice, plus factories pumping out greenhouse gases. With these steps, in about 200 years, Mars as a crater could warm above freezing. That means stable liquid water for the first time, and plants growing outdoors. Next, pioneers will plant tons of greenery. Photosynthesis turns CO2 into oxygen, so settlers can ditch masks and breathe free. By then, humanity won't just own a house or city in space, it'll have a whole planet. Picture floating in a Martian airship, gazing at lush forests and flowing streams. You might forget this was once barren, red dust. To scientists and engineers, Mars is a beacon of hope, a gateway to deeper solar system exploration. But building moon bases and terraforming Mars requires resources. Where will they come from? That leads us to asteroid mining, the fourth frontier in space exploration. All space projects need astronomical funds and materials. Asteroids could be the key, offering rich resources. Asteroids are small celestial bodies orbiting the sun, way tinier than planets. So far, we've found about 700,000 asteroids in the solar system, most under 100 kilometers wide. In short, asteroids are Shanghai-sized dirt clumps packed with wealth, loaded with iron, nickel, manganese for industry, and precious platinum group metals. A single platinum-rich rock 500 meters wide could hold as much platinum as all ever mined. Asteroids could spark a massive space gold rush for humanity. Sharp-nosed pioneers have already jumped into action. Back in 2012, Avatar director James Cameron announced at Seattle's Museum of Flight the founding of Planetary Resources, targeting water and precious metals on asteroids. Besides Cameron, investors included Google co-founder Larry Page, former NASA Mars mission director Eric Anderson, and other celebrities. They claimed asteroid development would generate billions in global GDP, providing the foundation for human prosperity. In early 2018, the company successfully launched a mini satellite, laying technical groundwork for future asteroid probes. Additionally, Luxembourg's deputy prime minister officially declared in 2016 they'd added asteroid mining to their agenda. For humanity, asteroids are distant but very real gold mountains. Some predict the early 21st century space race will focus on asteroids. Soon we may see cargo ships shuttle between asteroids, Earth, Moon, and Mars, building cosmic highways to fuel humanity's grand plans. While the blueprint's beautiful, becoming true solar system masters requires solving many challenges. The future of space examines key challenges we'll face and offers solutions. First challenge, getting powerful propulsion, whether rockets or spacecraft. Moving people and cargo to space demands serious thrust. Our most familiar space propulsion, rockets. The most powerful rocket ever? America's Saturn V, with near-Earth payload capacity near 120 tons and thrust equal to 30 Boeing 747s. After Saturn V retired, SpaceX's 2018 Falcon Heavy took the crown, the one that launched a Tesla into space. Its payload capacity is just over half of Saturn V's. For future super rockets, fusion power may be our best bet. Back in the 1970s, Americans proposed fusion rocket concepts, using nuclear fuel to create high-temperature plasma for spacecraft thrust. To this day, it remains the most thoroughly developed fusion rocket concept, inspiring numerous films. From Alien to Avatar, countless movies have featured fusion engines as standard propulsion for massive starships. In 1960, another American physicist, Robert Bussard, pioneered differently with his Bussard ramjet concept. His theory: interstellar space isn't pure vacuum, but filled with sparse matter, interstellar medium. Though extremely low density, this matter permeates everywhere. If we could harvest it as fuel, spacecraft could achieve practically unlimited range. But before that future arrives, long-distance spaceflight's second challenge is refueling. Actually, space refueling tech dates back to the Soviet Salyut program. Salyut 6 achieved on-orbit refueling in 1978. Later, the US and China mastered it too. But current space refueling mainly serves large craft like space stations. It only recently has satellite refueling tech become a global research focus. By early 2018, nearly 20,000 satellites had been launched worldwide. The catch? Most are disposable. Once fuel depletes or solar panels fail, we helplessly watch expensive satellites become junk. Watching helplessly. In 2016, NASA signed a 100 million or more contract with a commercial firm to build mobile space gas stations, extending satellite lifespans. This prevents waste, reduces space junk, and preserves cleaner near-Earth space for exploration. Speaking of space junk, that's the third major challenge in deep space exploration. Space debris-caused accidents and disasters are all too common in aerospace history. In 2009, America's Iridium-33 collided with a defunct Russian satellite, the first full satellite collision in history. As you can expect, with more spacecraft launching, such accidents won't be the last. Currently, space debris is increasing by 2% to 5% annually. If this keeps up, in 300 years, low Earth orbit could be clogged with space junk. Or worse yet, debris from collisions can trigger more chain reactions, potentially forming a debris belt around Earth that blocks humanity's path to space. Right now, the main way to avoid space debris is just dodging it. But to prevent things from worsening, scientists have proposed many cleanup methods. For example, using laser brooms to push or vaporize debris, good for small junk under 10 centimeters, or space nets made of strong fibers to catch fragments, or launching active satellite cleaners. These satellites actively fly to a large degree, grab it to handle satellite-sized junk. And there's the ultimate suicide cleanup method, like launching another craft to dock with a dead satellite and drag it into the atmosphere to burn up. Of course, all these are stopgaps. The real solution is reducing garbage at the source. The ISS program manager says the station has strict policies. Only naturally degradable stuff can be tossed into space to burn up in the atmosphere. It seems environmental awareness has reached beyond the atmosphere. With a dual approach, we can have a clean and safe near space. Besides space junk, the fourth big challenge in space exploration is invasive alien species. Soon after humans entered space, scientists realized spaceflight pollution could be bidirectional. What does that mean? First, alien materials brought back could pollute Earth. Countless sci-fi movies have depicted the horror of alien invasions on Earth. The most famous is Alien. Second, spacecraft we launch could pollute other planets, wrecking native environments with unpredictable consequences. To prevent this bidirectional pollution, the UN enacted the Outer Space Treaty, mandating that all probes sent to other celestial bodies must be sterilized. This measure is called the Planetary Protection Protocol. Astronauts returning to Earth also undergo strict quarantine. The largest planetary quarantine actually happened during Apollo. When Apollo 11 astronauts returned, their first act wasn't celebration, but spraying disinfectant on each other. Only after their 3-week quarantine could they meet the public as heroes. Future asteroid and Mars missions will need tailored two-way quarantine measures to protect both Earth and target celestial bodies. Space is so vast, humans so tiny within it. Future space exploration can't happen without astronauts. The final space challenge? Pioneers face huge psychological and physical hurdles. Depending on mission length, astronauts face space motion sickness, circadian disruption, and muscle atrophy. Zero G causes nausea, vomiting, drowsiness, headaches, called space adaptation syndrome. This syndrome can't be fully prevented yet, only managed through training and meds. But here's good news, most symptoms disappear within days. Circadian disruption stems from altered day-night cycles. Space medical teams combat this with strict 24-hour schedules and artificial lighting to overcome space jet lag. For muscle atrophy, exercise is the best solution, plus medication. Beyond physical issues, astronauts may face psychological struggles. NASA research shows ideal candidates are sociable introverts, cooperative teammates who can handle space isolation. But regardless of prep, after 30 days, extreme stress can trigger hostility between crewmates, even in ground simulations. In 1999, two Russian cosmonauts actually fought during ground-based training. It's hard to imagine that elite astronauts chosen from thousands could do such a thing. Clearly, the space environment imposes immense psychological pressure on people. More worrisome is that as space exploration advances, space flights will become ever more frequent. At that time, it won't just be professional astronauts working in space, but also thousands of ordinary folks. Their training time might be much shorter than current astronauts. In the future era of cosmic exploration, how do we solve crew members' psychological issues? This could become the key factor affecting mission success or failure. Now let's recap the main content of the book, The Future of Space. This book depicts humanity's future in the solar system and mainly answers two questions. First, what are the development prospects for humanity in space? We'll build leisure resorts, larger space stations, and even space cities, plus lunar bases and terraformed Mars. Then, to complete these constructions, we'll also need to develop asteroids. Second, what difficulties do we need to solve to realize this beautiful blueprint? First is stronger propulsion capabilities, then refueling. Next, we face space degree interference and prevent bidirectional alien species invasion. Finally, we must address pioneers' physiological, health, and psychological issues. Despite so many obstacles, humanity insists on advancing into space because we're always pursuing a better future. And because venturing into the unknown is human nature, humans emerged from Africa, crossed oceans and mountains, leaving footprints across continents and stars. It once guided fearless sailors to new continents, and humanity's next steps will be to distant stars and space. That wraps up our interpretation of The Future of Space for you. Book notes are below the audio. See you tomorrow.